You are standing in front of a fireplace. Maybe it is winter, maybe the room is cold, and the fire is doing what fires do, dancing, shifting, throwing light across the walls in that particular way that has held human attention for 100,000 years. You are watching the flames, orange, yellow, the occasional blue at the base. The heat on your face is real and immediate. The light is warm and alive. And you know without thinking about it that you are watching something burn. Wood going in, heat and light coming out, flames rising, smoke curling upward, fire. You have seen fire your entire life. You have lit candles and matches and gas burners. You have watched campfires and wildfires in the blue ring of a kitchen stove. Fire is not mysterious to you. Fire is one of the most familiar things in the world. You know what it is. It is a thing, a physical, visible, tangible thing that burns and produces heat and light and eventually goes out. It is matter in a state of combustion, releasing energy. But here is the question I want you to sit with before we go any further. What if fire is not a thing at all? What if the flame you are looking at has no matter in it, no solid, no liquid, no conventional gas you could bottle and store, and is instead something physics barely has a comfortable category for? What if the question of what fire actually is has an answer so strange that the word burning, the word flame, the word fire itself, all turn out to be labels we attach to a phenomenon we never properly examined? What are you actually looking at when you look at a flame? Let me tell you something. Fire is one of those subjects where the gap between what everyone knows and what is actually true is, I think, unusually large. People have a working understanding of fire that is good enough to use fire safely and productively. But good enough to use is not the same as correct. The map is not the territory. And the map we carry around of what fire is has some features on it that correspond to nothing in the territory at all. If you want to understand how the universe actually works, not just how it looks, but how it works, hit that subscribe button. Let's find things out together. Let us start with what is actually happening in a flame at the molecular level, because that is where fire actually lives. You have wood. Wood is primarily cellulose, long polymer chains made of carbon, hydrogen, and oxygen atoms, locked together in molecular structures that are stable at room temperature. When you heat wood to its ignition temperature, roughly 300 degrees Celsius, those molecular bonds begin to break. The long cellulose chains fragment. Smaller volatile molecules, gases, are released from the wood surface and rise upward. These gases include carbon monoxide, hydrogen, various hydrocarbons. They are flammable. They mix with the oxygen in the surrounding air, and in the presence of sufficient heat, they react. This is combustion. Atoms rearrange. The carbon bonds with oxygen to form carbon dioxide. The hydrogen bonds with oxygen to form water vapor. Both of these reactions release energy. The products are at a lower energy state than the reactants, and the difference in energy comes out as heat and light. The reaction is self-sustaining because the heat it produces is enough to keep breaking apart more fuel molecules, releasing more gas, sustaining more combustion. Fire is a self-powering chain reaction. It feeds itself until it runs out of fuel or oxygen or gets too cold. Stay with me because this is where the standard explanation stops and the interesting part begins. What is the flame itself? Not the wood, not the gases, not the products. The visible flame, the orange and yellow thing you are looking at. What is that? Here is the analogy I want you to hold. Imagine a waterfall. The waterfall is real. You can see it, hear it, feel the spray from it. It has a shape, a location, a temperature. But the water in the waterfall is not the waterfall. The water is always moving through, always different water, always leaving. The waterfall is the pattern, the persistent shape maintained by the continuous flow of material through it. If you stop the waterfall disappears instantly because the waterfall was never the water. It was what the water was doing. A flame is exactly this. The flame is a pattern maintained by the continuous flow of hot gas through it. The molecules you see glowing orange are not staying in the flame. They are passing through it, rising, reacting, radiating, moving on, being replaced by new molecules from below. The flame you watch for an hour is not the same matter for more than a fraction of a second at any point. It is a shape, a persistent structure maintained by the constant flow of material and energy. If you remove the fuel, the pattern collapses immediately. Because the flame is not a thing, it is a process, a verb pretending to be a noun. Do you see what happens? You look at the flame and your brain, which is very good at identifying persistent objects, treats it as a thing that is there. But it is not a thing that is there. It is a process that is occurring. There is a profound difference. Now let me tell you where the light comes from, because this is the part that connects to something deep. The orange and yellow color of a typical flame is not coming from the combustion reaction itself. It is coming from soot, tiny particles of incompletely burned carbon, clusters of a few hundred to a few thousand carbon atoms, heated to incandescence by the surrounding combustion. These particles glow the way any hot object glows, by thermal radiation, the same mechanism that makes a heating element on a stove glow red, the same mechanism that makes stars shine. The color tells you the temperature. Orange flame is roughly 1,000 to 1,200 degrees Celsius. A hotter flame, a blue flame like the base of a candle or a gas stove burner, is actually cleaner burning, less soot, the light coming more directly from the excited molecules of the combustion products themselves. Now I want to take this deeper, because the light from a flame is a direct window into quantum mechanics, and most people have walked past this window their entire lives without looking through it. When a molecule or atom is heated, its electrons absorb energy and jump to higher energy levels, higher orbitals further from the nucleus. They cannot stay there. The higher energy state is unstable. After a very short time, nanoseconds typically, the electron falls back down to its ground state, and the energy difference between the higher level and the lower level is released as a photon of light. The color of the photon, its frequency, its wavelength, is determined precisely by the energy difference between the two levels. Different atoms and molecules have different characteristic energy level spacings, which means they emit light at characteristic frequencies. This is why a sodium flame is yellow. The sodium D lines at 589 nanometers are the specific photon energies emitted when sodium's outer electrons fall back to their ground state. This is why you can identify elements by the color of the light they emit when burned. The flame is a quantum event, happening trillions of times per second, each photon a record of a single electron falling from one energy level to another. Let's be honest about what you are looking at when you watch a fire. Every photon of light that reaches your eye from that flame was produced by a single electron transition in a single atom or molecule. The warmth on your face is trillions of these events per second, each one a quantum of energy released as an electron fell to a lower state. The dancing, living, continuous thing you perceive as flame is the aggregate of an almost incomprehensible number of individual quantum events, each one instantaneous, each one discrete, summing into something that looks smooth and continuous and alive, but is, at the bottom, a statistical phenomenon, a crowd behavior emerging from individual quantum jumps. This is the part that keeps me up at night. Fire is plasma adjacent. I want to be precise about this because the word plasma is often misused. A plasma is a state of matter in which electrons have been stripped from their atoms, producing a mix of free electrons and ions. A flame is not a full plasma. It is not hot enough typically to fully ionize the gas, but it contains partial ionization. There are free electrons moving through the flame. There are ions. A candle flame, measured carefully, has an electrical conductivity significantly above that of ordinary air. You can deflect a candle flame with a strong electric field because the charged particles in it respond to the field. Fire is not quite a solid, not quite a liquid, not quite a gas, not quite a plasma. It is a partially ionized, chemically reactive, radiating, self-sustaining process that occupies a category that our standard list of matter states, solid, liquid, gas, plasma, does not cleanly accommodate. Ask a physicist what state of matter fire is, and you will get a careful, hedged answer, because the honest answer is that fire is not primarily a state of matter at all. It is a reaction, a process, a pattern. Now here is the uncomfortable implication, and I want to state it plainly. We have been looking at fire for 100,000 years. It is the first technology. It is the thing that separated us from every other species. The controlled use of combustion to cook food, to provide warmth, to reshape materials, to signal across distances, to clear land, eventually to drive engines and generate electricity. Civilization is substantially the story of what humans have done with fire. And for 100,000 years of looking at it, the vast majority of people, the vast majority of the people who used it, studied it, wrote about it, painted it, worshipped it, controlled it, had no idea what it actually was. Phlogiston. Before the late 18th century, the best scientific explanation for combustion was that flammable materials contained a substance called phlogiston, which was released during burning. The ash left behind was the dephlogisticated remnant. This theory was coherent enough to make predictions, wrong enough to be completely false. It took Antoine Lavoisier's careful experiments with oxygen in the 1770s to demonstrate that combustion is not the release of a substance, but the combination of fuel with oxygen, a gain, not a loss. We had the direction of the process backwards for the entire history of science up to that point. We were confidently wrong about fire for longer than civilization has had writing. Now, the visceral thing, the thing that lives in your body right now, the heat you feel from a fire is not hot air reaching you. Across a room, most of the warmth from a fire arrives as infrared radiation. Photons in the infrared range, produced by those same electron transitions and molecular vibrations in the flame, traveling to you at the speed of light and absorbed by the water molecules in your skin, which vibrate faster in response and register as warmth. The heat on your face from a fire is light. You are being warmed by photons. Quantum events in a flame across the room, each one a single electron falling to a lower energy state, are depositing their energy into the water in your skin. The warmth of a fire is the quantum of a flame, absorbed by the quantum of you, experienced as the most ancient human comfort there is. Every time you have warmed yourself by a fire, you have been participating in a quantum exchange between electron transitions in a plasma-adjacent reaction and the molecular vibrations of your own body. You just didn't know it. Here is the reframe, and the precision of it is what makes it more beautiful, not less. Fire looks alive. It moves, it responds, it consumes, it grows, it dies. Every human culture has at some point treated fire as a living thing, and you can see why. It behaves like life. It takes in fuel, releases energy, maintains its structure against the environment, propagates itself, responds to conditions. And what I have just told you suggests that this intuition is not entirely wrong, even though fire is not biologically alive. Fire and life share a deep structural similarity. Both are patterns, maintained by the continuous flow of matter and energy through them, persisting not because they are made of stable stuff, but because they are self-sustaining processes. You are not made of the atoms you were made of 10 years ago. You are a pattern that has been continuously replacing its material while maintaining its organization. Fire is the same. The difference is complexity and duration in the presence of information. Fire is what a living thing looks like when you remove the information, the pattern without the memory, the process without the purpose. And yet it has kept us warm for 100,000 years, and it is beautiful. And now you know what it actually is, which does not make it less beautiful. It makes it more. If this twisted your brain a little bit, good. That means it's working. I'll see you in the next one.